Last class we were talking about infinite geometric series with word problems, and we talked about number 2 with a ball being dropped. So now we're going to go ahead and we're going to start talking about number 3. So number 3 says a pendulum that is released to swing freely travels 18 inches on the first swing, and then on each successive swing, the pendulum travels 80% of the distance of the previous swing. What is the total distance of the pendulum swing? So if we think about it, a pendulum, looks something like this. So I'm just thinking about something that's going to swing and then swing back. So it's going to make its first swing, and then it's going to swing back 80%, but then it swings back that same 80%, and then 80% of that, so on and so forth, all the way down. So this first swing that it makes is 18 inches, but then the second swing is 80% of 18 inches. So 80%, so I do 18 times 0.8, I get 14.4. So this right here is 14.4. So after 80% of 18, so then it goes 14.4%, 14.4 inches, and then it swings back 14.4 inches. And then it takes 80% of 14.4, which is 11.52. So then this is 11.52, and then it swings back 11.52, and so on and so forth. And if you notice that from here down, it's following a pattern, and that's a geometric sequence because I'm multiplying it by 80% each time that it's happening. So I want to go ahead and I want to try to convert this into a geometric sequence so then I can turn it into a geometric series to determine the total distance. So obviously I have this first 18, which I need to account for. That's going to be 18 plus. So then how did I get 14.4? Well, I did 18 times 0.80. Times 0.8, which is 80%. And then that was my first 14.4. So then I had to do the exact same thing. So 18 times 0.8 to get my second 14.4. So then to get 11.52, I had to do 18 times 0.8 squared because it took 80% of 18, and then I took 80% of that number. And then that happened again because it has to make 2 swings to make that full rotation before it can go back. And then this just keeps going on forever. So notice that here I have my geometric sequence. So I still have 18, but now if I combine like terms, I have 36 times 0.8 plus 36 times 0.8 squared, and then obviously the next one is going to be 36 times 0.8 cubed, and then so on and so forth. So if you notice, I have a geometric series right here, and since this goes on indefinitely, and we're not sure when it ends, it's an infinite series, so I'm going to use the infinite series formula. So the infinite series formula is a sub 1, so the first element in my sequence, which is this number, so 36 times 0.8 over 1 minus r. So my common ratio in this problem is 0.8. But I cannot forget the initial 18-inch swing in the beginning. So now, honestly, I would type this into my calculator, and I would say, okay, 36 times 0.8, and then I would divide that by 1 minus 0.8. I get 144, and if I add 18 to that, I get 162 inches. So if I were to swing a pendulum 18-inch, if I were to swing a pendulum and it was released 18 inches from its first swing, that by the time it would end, if it traveled 80% of the distance each swing, it would use 162 inches. So now I want to go ahead and I want to actually start talking about these word problems. We talked about these word problems a little bit on the front side, but I now want to mention it a little bit on the back on these problems here. The big thing with these problems is there's one word that really causes these problems to change. So it says the original value of a car is $18,000 and it depreciates, meaning it loses value, 15% each year. What is the value of the car after 3 years? So because I see the word after, if I highlight that in a different color, When I see the word after, that just means I'm using the exponential decay formula we learned last unit, which is P equals A1 minus R, to the T power. When it means after, it's including that third year, so that means 3 years have successfully occurred. So it would be 18,000 times 1 minus 0.15 to the 3 years. So here, if I type all that in my calculator, I get P equals 45,000. Wait, that's not right. Let's type this in my calculator, my answer key I don't really like. Let's see. 1 minus 0.15 to the 4th power. Oh, that's much better. So this is $9,396.11. So what this means is after my 3 years, my car is going to be worth $9,000, where instead it was worth $18,000. If I had have tried to turn this into a geometric series would be the right word because I'm turning it into an explicit formula. A sub 1, and the first year, it's 18,000. But 18,000 is year 1. And then after 3 years, well, actually, usually 18,000 is year 0. And then year 1, year 2, year 3, that actually means N is 4. Because I have year 0, year 1, year 2, year 3. The day you buy it, it's here. Then the first year, then the second year, then the third year. So if I was going to turn this into an explicit formula, I would want N to equal 4. So it would be N minus 1, which would be, so I do N minus 1. And then my R, remember, we have to take 100% and subtract it since it's depreciating. So R is actually 0.85. So then I would plug in 18,000 times 0.85 to the 4 minus 1, which is 0.85 to the 3rd power times 18,000. And I noticed I made a mistake on this guy here. It's not how much that should be. It should be, no, my calculator doesn't have the right answer. Hold on. $11,054.25. And the nice way is I checked myself so I knew it wasn't going to be right. So on the after the 4th year, or after 3 years, that means A is 4. It'd be $11,054.25 as well. So whenever you see the word after, I would use the exponential growth or decay model that we learned last unit. If we look at this last problem, it says if your starting salary was $35,000 and you received a 6% increase at the end of every year for 16 years, what would be the total amount in dollars you have earned over the first 16 years? And instead of over, I'm going to say during. So can you actually type that out? And let's write during. So it says, if your starting salary were $35,000 and you received a $6,000 increase at the end of every year for 16 years, what would be the total amount in dollars if you have earned during the first 16 years you have worked? So because it's talking about during, and it's not after, it doesn't equal 16 yet. So it really would be 16 minus 1, only 15 years have occurred. So because I see the word during, I am going to turn this into an explicit formula. So I'm going to say A sub n equals 35,000, because that's my first year, how much it is. And then I received a 6% increase. So R is really 1 plus 0.06, because it's 100%, and since I'm increasing, it's going to be 1.06. You can also think about it as, since it's increasing, it'd be 1 plus 0.06. If it was decreasing, it'd be 1 minus 0.06. And then since it says during, 16 years haven't happened yet, so I have to do 16 minus 1. So 35,000 times 1.06 to the 15th power is $83,879.54. So what this means is that during this first 16 years, I have earned this much money if I receive a 6% increase at the end of every year. So the one thing when I was doing this, I remembered if I see the word after, my brain just goes, all right, use exponential formula. Exponential growth or decay. If I see the word during, use geometric sequence, or I do n minus 1. So if I use after, I'm using n, and if I see during, I'm using n minus 1. All right? So now let's go ahead and let's talk about writing a repeating decimal in lowest terms. So I could easily probably type this in my calculator, figure this out an easier way, or a different way, but I can do this by using geometric series. So I always first look at how many digits repeat. So notice the first 2 digits repeat. So every 100th term, it repeats to 24. So if I take 24 out, 24 times 0.01 is going to be 0.24, right? So that's this first piece. And then if I do 24 times 0.01 times 0.01, that's going to be the first digits of my repeating decimal. And then if I do 24 times 0.01 to the third, which is 24 times 0.01 times 0.01 times 0.01, that's the first 3 times it repeats. So notice I'm following a common pattern. So I can turn this very quickly and easily into a geometric sequence explicit formula. Notice this term is my a sub 1, and my common ratio is 0.01. So s to the infinity is a sub 1 over 1 minus 0.01. So 24 times 0.01 divided by 1 minus 0.01. I get the decimal, and then I hit math, enter, enter. This equals 8 over 33. If I go ahead and I look at this next one, I notice I have a whole number, so that's just going to come out 3 plus. And then I ask myself, okay, how many times does 5 repeat? Well, it repeats once it repeats again, it's only 1 digit, so that's the 10th place. So 5 times 0.1, that's going to get me my first 5. And then 5 times 0.1 squared, that's going to get me my 2 5s. And then 5 times 0.1 cubed, that's going to get me my first 3 5s, and so on and so forth. So I still have 3, but now I can turn this into a geometric infinite series. So a sub 1 is 5 times 0.1, and then it's 1 minus r, which is 0.1. So 5 times 0.1 divided by 1 minus 0.1. And then if I hit math, enter, enter, I get 5/9, but I have to remember, so now I have 3 plus 5/9 to add 5. So I get 32 over 9. So I recommend pausing this video and trying the last one on your own. However, if you need help or you want to check your answer, it'll be on the screen. So 1 is my whole number. So now I highlight the first, how many digits until it repeats. So the first 3 digits. So it's 236, and then it's my thousandth place, 0.001. So then it just repeats 236. To get the next one, I got to go 6 decimal places. So that's 0.001 squared, and so on and so forth. So I have 1 plus. So now I can turn this into a geometric infinite series. A sub 1, 1 minus r. So now I would type that in 236 times 0.001 divided by 1 minus 0.001 plus 1, and then hit math, enter, enter. I get 1,235 over 999.